In example 2, we need to solve for the variable indicated. We want to state our excluded values. So our excluded values here are simply the values that make the bottom of any fraction 0. So we've got 2b minus 12 cannot be 0, or b minus 6, oops, that's a b, minus 6 cannot be 0. Solving this one, we'll add 12 then divide by 2, so b cannot be 6, and then we'll add 6 here, and we get actually the same excluded value. So b cannot be 6. Now we'll turn our attention to actually solving this one. What I'm going to do is I'm going to try to get all the denominators to be the same. This is just one technique that does work. So remember, this is over 1. So I need to multiply this fraction by 2b minus 12 over 2b minus 12. If we only multiplied this bottom by 2, we'd have the same thing, so we'll multiply the top by 2. So we've got 1 over 2b minus 12 minus, and then using the distributive property, it's going to be 4b plus 24. And that's going to be all over, let's see here, and I'm going to make that a negative up here so that we clear that up a little bit. This will be 2b minus 12 in the bottom, and then 14 over 2b minus 12 would be the right-hand side of the equal sign. Notice how we have a common denominator here, so we're allowed to set the numerators equal to each other. We'll solve this one first by combining the 1 and the 24 to be 25. We'll subtract 25 now. Negative 4b is equal to, and this should be, I think, negative 11. We'll divide by negative 4, and b will be 11 over 4. Notice that's not 6, and so we're okay with this. We'll try a different technique with this one here on the right-hand side. We do need to make sure that we do our excluded values, though, for each one of these. So all we do is set any denominator of a fraction that has a variable in it not equal to 0. We'll subtract 5, so x cannot be negative 5 here. Then we'll subtract 15, and then divide by 3. And you'll notice that that's also negative 5, so this is actually our only excluded value. The technique I'm going to use right now is I'm going to multiply each one of these by 3x plus 15. We'll see what happens. So let's multiply this by 3x plus 15. We'll multiply this one by 3x plus 15, this one, I mean this term, and this term by 3x plus 15. Now notice how a 3 could be factored out here, and 3 times 6 is 18, so we can rewrite this as 18 times x plus 5. And you could also distribute the 6 and then factor that 18 back out, that's fine. So we have x plus 5 in the bottom equals 5 times 3x plus 15, all over 3x plus 15. And this one's going to be negative 4 times 3x plus 15. So notice here, these x plus 5s will cancel, the 3x plus 15 cancels, we're left with 18 is equal to 5. We'll do the distributive property here, minus 12x minus 60. 5 minus 60 is negative 55. We'll add 55 here. And we get negative 12x, switching sides on you. That's going to be 73. And we'll divide by negative 12 here on each side. And we'll get x to be negative 73 over 12. Notice how that's non-negative 5, so we're good to go. We've got a couple more to do. So we'll keep working on those here. In part C, I'm going to try to make all the denominators the same, but before that, I'm going to look for my excluded values. So y minus 1 can't be 0. Y plus 1 can't be 0. We'll add 1 and subtract 1 here. So we've got y is equal to 1, or negative 1, and actually y cannot be excuse me, equal to 1 or negative 1. Let's work on solving this one then. I'm going to multiply this by y minus 1, and let's see here, y plus 1, and actually we're not going to get common denominators here. I'm going to do this a little bit differently. So we need to multiply every term by that same thing, y minus 1, y plus 1, and y minus 1, y plus 1. How I decided on that is I looked at y minus 1 times y plus 1, and that's what I'm multiplying by. Excuse me. So I've got 6 times y minus 1, y plus 1. This next one, these y minus 1's will cancel. We've just got y plus 1. And then I'm going to have 6 times y minus 1, kind of getting in the business here of the other stuff. Y minus 1 times y plus 1 is y squared minus 1. That's a difference of 2 squares. Plus y plus 1. 6y minus 6 would be the next one if we use the distributive property. We'll do the same thing here. So we've got 6y squared minus 6 plus y plus 1 is equal to 6y minus 6. We've got a nice little quadratic. So we're going to want to try to get everything off to the left-hand side. We'll add 6 here. Notice that those will cancel. So we've got 6y squared, y minus 6y is negative 5y, plus 1 is equal to 0. There's a few different ways to solve this one. You can factor, complete the square, or any of those things. We'll try to factor this one using the AC method. So 6 times 1 is 6, and I know that negative 3 times negative 2 is 6, and they add up to negative 5y. With the AC method, all we're doing is just splitting that middle term up, and then we're going to factor by grouping. So we'll factor a 3y out here, leaving 2y minus 1. And then we'll factor a negative 1 out here, leaving 2y minus 1. So 3y minus 1 is equal to 0, or 2y minus 1 is equal to 0. Adding 1. 3y is equal to 1. Let me move this up a little bit. Or 2y is equal to 1. Divide by 2, divide by 3 here, and we get y to be 1/3 or 1/2. Either one of these is not 1 or negative 1, and this is by no means the only way to solve this problem for sure, but it does work. And we have 2 possible answers for this one. As we work with the one on the right hand side, that was off the screen here, let me line this back up for you. So we know that u minus 6 cannot be 0, or u plus 2 cannot be 0. So u cannot be 6 if we add 6 to each side, or negative 2. We'll need to be careful of those excluded values. The technique I'm going to use here is to try to get all of the denominators to be the same. So let me write this out for you. I'll show you what that looks like. I'm going to multiply this by u plus 2 over u plus 2. And then this 1 I'm going to change into u minus 6, u plus 2, over u minus 6, u plus 2. And then this next one I'm going to multiply by u minus 6 over u minus 6. So you'll notice that I've not multiplied any one of these fractions by anything other than 1. U plus 2 over u plus 2 here, u minus 6 u plus 2 here, and then u minus 6 over u minus 6 here. The benefit of this is now all the denominators are the same. So we're going to have u minus 1 times u plus 2 times u minus 6 u plus 2. And we've got u plus 1 times u minus 6 over here. Time to do a little bit of foiling. So this is u squared. Negative u plus 2u is 1u. Negative 1 times 2 is negative 2. U squared is just u squared. Negative 6u plus 2u is negative 4u. Negative 6 times 2 is negative 12. U times u is u squared. 1u minus 6u is negative 5u. And 1 times negative 6 is negative 6. We'll try to combine terms on this side. So we've got 2u squared. A u and a negative 4u is negative 3u. Negative 2 minus 12 is negative 14. This is a quadratic, so we'll try to move everything over here to the left-hand side. So we've got minus u squared plus 5u plus 6 2u squared minus u squared is just u squared. Negative 3 plus 5 is 2u, and negative 14 plus 6 is negative 8. That's all equal to 0. Lots of different ways to do this one. I think factoring is going to be easy if we can. So I got to find two numbers. When I multiply them, I get negative 8. When I add them, I get 2. So that's positive 4 and negative 2. U plus 4 could be 0, or u minus 2 could be 0. We'll subtract 4 from each side there and add 2, and we see that u could be negative 4 or 2. Notice how that's not either one of our excluded values, so we are good to go with these.